Okay, so let's talk about the natural history of these plants. So, as I had mentioned, angiosperms are kind of our youngest group of plants. They're really not dating back um, that long ago in the case of our natural history. But whenever we look at some of our older plant ancestors, it dates back quite a ways. So when you look at some of our organisms, such as our algae, and then getting into our non-vascular plants, such as our mosses, our bryophytes, for instance. They go back to the Ordovician period in time, which is, over 400 million years ago. So that's pretty substantial when it comes to the history of our of plants. Um, and so let me see here. Um, when you look at that, going back to this previous timeline, you see where these first plants were, and then you can kind of also see, if you're curious as to when were the dinosaurs, when were the mammals, when were the first birds, things of that nature. And so, of course, a lot of our land plants are existing during this time, where primarily we're going to see a lot of these aquatic organisms. And then over time, we get into more of our land animals, our dinosaurs, but it'll be many, many millions of years down the road before we get into even our first mammals. So kind of going back to this graph, again, your algae, your mosses are very, very old. And kind of from there, we get into what we call the Devonian era. And the Devonian area is pretty crucial with our plants, because this is where our vascular plants are appearing. So these are plants that contain internal tissue. And so things like your ferns are a really perfect example of very old vascular plants that have somehow survived over millions of years, that we still have many modern ancestors today. So, that's pretty brilliant. As we go through these natural timelines. There's many extinctions that go on, and of course, one of the biggest we see is the extinction of the dinosaurs. That we still have plants that have been able to kind of survive during these times of mass extinctions, or at least a a common ancestor that has similar DNA, that kind of you know um, help to bring forth some of these modern plants that we see. So going beyond the ferns, some of our other vascular plants that we see, a lot of gymnosperms. So gymnosperms occurring before in angiosperms. So our gymnosperms are our seed producers, right? So, of course, when we hear gymnosperms, we think automatically, our conifers. Um, but as we'll kind of talk about today, there are quite a few other plant species that do produce seeds as well. But they were kind of the first ones to appear. And then whenever we think of other plants going all along with our gymnosperms, of course, we think of cycads and ginkgos, which are, again, kind of our modern day, um, you know, old fossil plants, if you will. They're still kind of existing here, that we can actually see, but have predated over 300 million years ago. So, that's pretty amazing when you think of it. So just how widely these plants have been involved. So we're going to talk specifically with this class, we're going to talk about the type of plant fossils that we're going to see in Kentucky. So like, I really want to kind of focus on Kentucky's natural history, and what are we going to see? And so, in order to start that conversation, it's important that you all see a map of kind of the geologic state of Kentucky. Okay, and so we have different types of um, formations across Kentucky, and a lot of the rock that we see, the different types of rock, you know, uh, determine kind of the natural history timeline. And so just kind of looking at here, especially where we're going to be focusing on is where we are here in Western Kentucky in our Western Coalfield area. And so, so much of that involves kind of the Pennsylvanian, the shale, the sandstone, the coal that existed between 290 to 325 million years ago, as well as some of the clay, sand, and gravel from the Holocene and Pleistocene era. Um, so, we're going to kind of focus on those areas a little bit more today, but we'll talk about even kind of what we see more towards far west Kentucky as well. But this really gives you kind of a good idea of what type of rock that you're going to see, how old it is throughout Kentucky. And we'll mention a little bit about why this varies a little bit across the state. But definitely you're going to see some similarities to where we are here in the Western coalfields to out into Eastern Kentucky that has that Pennsylvanian rock as well. So this is a good reference, especially for kind of determining, what plant fossils can be found in this rock. So we're going to kind of go in depth a little bit with that. So let's start off with Devonian plant fossils. And so when we say Devonian, this is on our Kentucky map going back 360 to 410 million years ago. This is our shale and limestone. And so we're kind of seeing this Devonian kind of more into the central to eastern part of our state. Okay, so if you look kind of south of Danville, you'll see a little bit of that out into south, kind of central Kentucky. And so, where would you see this? What are the different things that you could see in the Devonian black shales of Kentucky? So primarily, you're going to see these fossilized logs called calixion. And with calixion, this is primarily from the plant called Archaeopteris. And Archaeopteris was what we call a seed fern, essentially. And actually, what's interesting is we have several logs of these seed fern trees that are found even in the Smithsonian Institute. So that's kind of cool. But you can kind of see based on these images, really kind of the top pictures, you're kind of seeing those fossilized logs that kind of showcase this very ancient tree. And that's what we're going to talk about today a lot. A lot of these, whether they be gymnosperms or kind of these seed producing plants, a lot of them are found in these fossilized logs. So specifically with the seed fern tree, this was probably what we would call the first true tree, if you will. It's not like when I say true tree, it's really not in regards to like modern day trees that have a very woody structure. Most of the tree-like plants that we had millions of years ago are going to be still pretty herbaceous, kind of non-woody. We'll kind of talk about, kind of their structure here in a minute. But these were tall plants. So it's weird because we say fern, and of course, we think of ferns being, fairly low growing. But this is really kind of called fern just because it has this fern-like foliage. This is kind of more similar to kind of a modern day conifer, if you will. But with that, it would form forests. So this would get quite tall and it would form forests in the late Devonian era. And it would have branching patterns to what we consider to be modern trees. So, of course, it looks very different than what we're used um, uh, to seeing modern day. But we'll kind of get more into that. So, I'm describing and explaining what you're going to see in different parts of Kentucky, just because if you happen to see these pieces in a museum, or if you happen to be going on some kind of hiking expedition, so to speak, or, just more than likely, just probably not seeing them kind of out, but if you see this kind of in the natural history museums, or you see this at some of our state parks, maybe they have, sections that you can look at. This is kind of the plants that you are going to see more than likely as fossils here. So, but yes, so most common one with the Devonian area is this Archaeopteris. So very, very cool looking plant. Now, if we go into the next area, this is the Mississippian plants. And so late Mississippian shales and sandstones. So if we go back to our map, so again, I'm kind of referencing this a lot. That's kind of that light blue coloration. So that 325 to 360 million years ago time frame. So you can see the Mississippian really does cover a good chunk of the state, kind of central portion, and then even kind of out to our west and south a little bit into Hopkinsville. This is going to cover some of the plant fossils that you might see there. So let's talk about these. So primarily here, you're going to see plant fossils of what we call scale trees and seed ferns. And we're going to get into that a little bit more when we talk about our Pennsylvanian plants. But a lot of these are preserved in coastal deposits that we still have. It's interesting when you hear the word coastal, but we have remnants of, very old coastal deposits still here in Kentucky. And so that's where we're going to actually see some of these preserved fossils of these different trees. Again, it's the same concept where there are these very tall trees that are reaching up even over 100 feet tall, but aren't quite the same as our modern day trees. Now, with this said, even though we have some coastal deposits in Kentucky, a lot of that, of course, has been washed away over time with the changing of the natural landscape, with kind of the movement of glaciers, and just kind of the changeover with the seas, the ocean, different things of that nature. But we do still have some left behind. It's just kind of a little bit harder to find. But primarily, we're going to be seeing with these scale trees and seed ferns. And like I said, we'll talk in depth about what these are here. So going from the Mississippian, let's talk about our Pennsylvanian. This is the thing, this is the section we're going to primarily be covering today. These are our most abundant plant fossils. They're found in these Pennsylvanian rocks. And the reason being, especially, again, let's go back to our section here, Pennsylvanian. So it's kind of that teal blue color if you look at the map. So our western and eastern coal fields area are the two sections that we're looking at. So the reason why we have so many plant fossils from this time is let's just kind of think about this for a second. This was a time, the Pennsylvanian period in our history, where so much of, at least where we are in the United States, was a very tropical, humid climate. Okay, so very different. Even though I would say Kentucky's kind of going a little bit subtropical at this point, but for the most part, you know, Eastern United States, kind of Midwest area, we think of more of a um, temperate zone. So looking at back during the Pennsylvanian period of time, it was very humid, tropical. And so with that, you had very lush forests. You had lush forests of these very tall trees that we're going to talk about. Again, non-woody trees really kind of had more of this kind of pithy core to them and thick bark. Um, a lot of these plants were spore producing, but then we did have some seed producing plants. Um, and what we find with this kind of area, of course, this is, I mean, for those of you that were kind of raised here, born here, you have an understanding of this, just the magnitude of how many of these fossil plants we have because of the amount of coal we have. So it's not all a coincidence. So let's kind of give a definition of what coal is. Okay. Coal is fossil peat. You know, coal is the peat, which is the accumulation of plant debris. It's the remnants of these plants that were back during this time period. And so really where we are in Kentucky, both east and western coalfield have an abundance of this plant debris. And that's because there at the time, again, you had these lush forests. You had these lush lowland forests. And so, that accumulation of all those plant fossils over time really helped to just add on and on and on layers of this fossilized peat. And so, which we use today as coal. And so really, I think a lot of people tend to forget, what coal really is. A lot of people in their minds probably think of coal as just a form of rock, but truly coal in the term of fossil fuel literally is a fossil of plant debris. And so if we really want to thank plants, not only for them providing us with food and medicine construction materials, but they are essential to, warming our homes and running our cars. I mean, whenever we use, coal in any aspect, it is using this very ancient plant material. And so I can say that I can be very grateful for plants. Uh, for providing that. But with that, when we get into these coal fields, of course, we're using up quite a bit of this fossilized plant material. Um, and for those of you that are familiar, have worked in the coal industry or not, sometimes may not always be, sometimes it can be a little problematic for coal miners in that if they are underground, some of these fossilized plants um, can form are from tree stumps. These tree stumps, these tree logs, and miners kind of refer to them as these kettle bottoms. Kettle bottoms. And bottoms are kind of this hazard, really severe hazard to miners because they're kind of up on the roof of that, on that underground mine. And so they could potentially fall. Those fossilized logs could potentially fall on coal miners once the coal around that area has been removed. So it can be quite a severe hazard. But that's what they experience is, not just that rich, dark, black coal that we kind of look at, but you're going to see those remnants of, again, tree logs, stumps, things of that nature. Um, So let's kind of talk a little bit about what plants are going to be making up this coal. You know, what were the plants that were here during that time frame? What are we seeing fossils of during this time that is very prevalent of where we live here in Kentucky? So let's kind of break that down in the next few slides. So let's start with the first one. Let's talk about scale trees. So scale trees are lycopods. They're related to the modern day club mosses and ground pine, which if you all are familiar with club mosses, these are very small plants. And so it's always interesting when you hear of an ancestor, so to speak, that really towered um, and thrived in kind of that prehistoric tropical landscape. But now its modern ancestors are, you know, are pretty small and I don't want to call any plant insignificant because all plants are important, but you know, very much overlooked, I guess you could say. Um, but with this scale trees, and you'll kind of see in the next pictures a little bit of what they look like. You can kind of see a little bit in this top picture of the size of it. But these did get quite tall, over 100 feet tall. And why it was called a scale tree, and you can kind of see here in the picture in B, you know, what the bark looked like. But it was called a scale tree because the bark kind of resembled that of the scales of a snake. So it's pretty cool. And then you can even see the cone that it produced in A, that you can even see the cone, the bark, and then also the root to really kind of gauge an idea of the full structure of what this plant was. And so kind of one of our more common scale trees we see is one called stigmaria, one that we see commonly in our coal fields. Um, and again, a lot of these stumps that we see are common in our deep coal mines that may be a potential hazard for those that are mining the coal. So, but scale trees are one of the first things that we see. So again, very neat plant, very unique looking. I mean, that's the thing. It's like it's hard to even imagine these plants the way they were compared to our modern day forests because it was just very different visually. Um, so let's talk about some of the next plants. Let's talk about a few more that are also prevalent around here. Um, so the next one is kind of a relative to our horsetails, and that's the Sphenopsida. So Phenopsida was again, it's kind of an ancestor to our horsetails, our modern day horsetails that we see. They're closely related. We refer to a lot of these as calamites. And again, similar to the scale trees, these got over 100 feet tall. These got fairly large. Okay, and so you can kind of see in the picture a visual, and also what are some of the fossilized components to them that you see. And I will say, when it comes to plant fossils, you know, if you can get a good fossil that you see the actual leaf arrangement, that's pretty spectacular. That's pretty hard to find. A lot of times, many of our fossil samples just are not there when it comes to looking, actually being able to see the preserved leaves of the plants. So if we do find one, that is a real treat. It really is. So another plant that we look at is our Phyllocopsida, and our Phyllocopsida um, are what we call our true ferns. So you may have heard me mention seed ferns earlier, but also true ferns. So it gets kind of confusing because we're throwing the word fern all around. But let's think of this way. Our modern day ferns are spore producers. Okay. And so with Phyllocopsida, these would be kind of our one of our closest ancestors, relatives to the modern day ferns. The Phyllocopsida actually produce spores, unlike what we'll talk about are the seed ferns. So these actually do produce spores to help reproduce, to help form new plants. Because our modern day ferns have a very interesting life cycle between the gametophyte stage, the sporophyte stage. Now, at this time, millions of years ago, during this Pennsylvania era, these ferns were not small. Again, they're not kind of like more of the low growing ferns we have in our woodlands today. These are very much like tree ferns. Now, we still have a few modern day tree ferns that we kind of see on the other side of the world. That's still prevalent in some of our areas, but very much these were relatively tall tree species. Not quite maybe getting as high as some of our scale trees, but still very substantial. That was taking over the canopies of some of our prehistoric forests. Now, in contrast to these true fern ancestors, we have what we called seed ferns. Again, seed ferns, not really fern ancestor, okay? These are called artritosperms. With artritosperms, these are actually all extinct now, okay? So these are no longer prevalent in the modern era. But we call them seed ferns because as we look at the fossils, we can see that the fossils had that resemblance of fern foliage. So that's why they were getting that common name. However, they were not really a fern relative because these were seed producing and not spore producing. So just to kind of distinguish between the two. But well, we'll go into this one first. Let's talk about some of our gymnosperms, ancient gymnosperms first, and then we'll get into kind of the picture of it all, the size. So also, again, we're still in the Pennsylvanian era. Again, we're still kind of focusing on these plants that we're seeing here in our coal fields, is the Gymnospermopsida. And so you can kind of tell from that name, gymnosperm. So again, these are seed-bearing plants. So conifers, chordates. I apologize, I did not spell ginkgo right there, just seeing that now. And then our seed ferns. So again, seed-bearing plants. These were found, these were the only seed-bearing plants found. Okay, so again, our flowering plants were not in existence yet. Okay, so of course, our modern day angiosperms or modern day flowers, they produce the flower gets fertilized, the flower produces a seed of some kind, right? We didn't have that yet. They did not come until well, million years later. Again, kind of looking back to that timeline of that 100 to 150 million years ago stage. So every fossil that we're seeing are of these gymnosperm type plants, these seed producing plants. And so you can kind of see good examples here of kind of the foliage that they look like that's imprinted in on this rock. Okay, so you had those seed ferns, you have early conifers, you have what we also will refer to as chordates. Chordates are strap-leaved trees, and basically because they had strap-like leaves. But also what's interesting with their seeds is they had winged seeds. And so we kind of think of a lot of our modern day trees, especially that have winged seeds, to help with, being able to become, wind dispersal, of things of that nature. And so these are some of the trees that we actually saw that had already evolved this unique characteristic of having a wing seed that can be used for dispersal. And so you have that in these prehistoric forests of how are these trees spreading? You know, how are they getting around, of course. And so you have means of the seed dispersal. And of course, at the time, you still had wildlife as a means of helping with seed dispersal as well. Um, but with these cordate trees, we see these very commonly in our coal fields. We have found the seeds, the limbs, the leaves pretty heavily in these regions. Unfortunately, we don't really have any kind of, so to speak, modern day plants that are like them now. These are an extinct species. All right. So you've heard me talk about all these plants, and it's like, okay, here's a better visual, okay, of what these looked like. All right, so we just talked about the chordates. So the chordates are again the strap leaf trees. Okay, we talked about the lycopods. The lycopods are those scale trees. Okay, and then we have the tree ferns, and then you have kind of the smaller but mightier calamites, which again, the calamites were our modern day horsetail rushes, our horsetails that are kind of branched off as from them. So these are primarily what you're seeing here, the main fossil groups that are found in the Pennsylvania coal fields of not only Kentucky, but in the US. And a lot of times, like I had mentioned, primarily we're finding the logs, the stumps of these ancient trees. So pretty cool, pretty substantial. So let's move out of those Pennsylvanian trees, Pennsylvanian plants for a second. And I want to mention the Cretaceous period and the Paleogene, Neogene period as well. Just because we do find a few fossilized remains, not quite as much as the Pennsylvanian fossilized remains, but nonetheless, we see a little bit. So I want to mention it. So Cretaceous period, this occurred about 85 to 95 million years ago, gravel and sand. This is kind of what we see more if you look on the map around land between the lakes. Okay. So around land between the lakes, we have some of that Cretaceous rock sediment. So that we may find. So let's go back and talk about these. Um, so this we it's very rare to find this. Again, you kind of have that small section there, but we do have some of the sands and clays in that region. A lot of it has been eroded away. A lot of it has kind of left the state of Kentucky, if you will, due to throughout the millions of years, kind of the coastal sediments, the sea level rise during those Cretaceous times. But what fossil remnants that um, we have found some evidence of some colified limbs and logs of trees, primarily gymnosperms, primarily gymnosperms. But there has been some evidence of some of our early angiosperms in these sediments. Again, they're kind of hard to find, and you're looking at more land between the lakes region. Um, but that is something that we do still see here a little bit in Kentucky. Okay, so let's go to So previously, this was called the tertiary period in our natural history. That's kind of been broken up into the Paleogene and Neogene eras now. And again, we're kind of looking more, if we go back to our map, at the Jackson Purchase area. So kind of going out a little bit into far west Kentucky. It's really hard to see a little bit with the map, but kind of that brown region. So very, very close, 30 to 60 million. I say very close. It was still 60 million years ago, but you know what I'm saying. Compared to 400 to 500 million years ago, it's relatively modern, so to speak. But of course, with this rock sediment, is primarily our clay and sand deposits. So what do we see here? So primarily, they are finding stumps, limbs, logs of some actual woody plants. So again, this is a much younger period of time. So we are seeing kind of more of the ancestors of our modern day trees, if you will, when our trees actually develop more of a woody structure. Again, not kind of that cory pith with that you saw with some of those other seed producing trees that were in the Pennsylvanian period. And so we are actually seeing some fossils of kind of more of these modern or what would look like modern day plants. Um, and with that, we primarily gymnosperms, primarily these conifers, but they have seen some remnants of angiosperms, some of our flowering producing trees. Now, with that said, like there's not really a good picture to show you. They've not been able to find any kind of evidence of leaves that were preserved well in this fossil. So in these fossils. So not really very exciting to show you, but just with that regard, there is still evidence in Kentucky of some early angiosperms that are found. But again, really primarily what I wanted to talk to you about today is those plants that we found primarily in the Pennsylvania era with our modern day coal fields. Um, I'll kind of get off on a quick tangent real quick because I feel like people would ask, and the question is not, it's like we're talking about plant fossils. The focus is on botany, of course, but it's like, well, will we find any dinosaur fossils in Kentucky? Um, and the answer is maybe. You may be able to potentially find dinosaur fossils in kind of our Cretaceous sediments. Okay. There's not really been a whole lot of research or studies done to kind of look for dinosaur fossils, but there could be potential that they exist, maybe in some of our Cretaceous sediments that are found in the Jackson Purchase area. But the problem that you're going to come across again is so much of this is gone. So much of it has been eroded away for over millions of years. But yeah, again, people may be asking, it's like where, because you find in certain regions of the United States where we have perfectly preserved dinosaur fossils, but not really so much around here, unfortunately. So yeah. Um, just wanted to kind of share that. Um, but with that, uh, I think that kind of concludes my presentation for today. So again, hopefully providing a little bit of a brief history into Kentucky, what we see for fossilized plants here in Kentucky. I will say that our goal as an office, as an extension office, is we plan on in the future doing a Master Naturalist program, Master Naturalist Volunteer program, very similar to Master Gardener program. And so one of the topics is kind of this paleontology, the paleobotany, get into the geologic regions of Kentucky. Well, a lot of that is going to be covered in the Master Naturalist program. And so this is kind of a little snippet of what you would hear in this course. So, kind of be on the lookout for that. We are talking about having this maybe for 2026, offering a Master Naturalist class. Of course, for those of you, well, all of you that are here, it's like we got to get moved in completely in our new building before we do that. But it is something that we're looking at. So basically what I'm saying is if this natural history component really interests you, then that is going to be a kind of a good chunk of what Master Naturalist covers. So just kind of be on the lookout for that. But anyway, I'm going to go ahead and stop recording. So